Thank you for your interest in Bharat AI SOC Student Challenge. This initiative, driven by ARM and ARM Education, aims to support skill development in India by encouraging students to tackle industry relevant problems and devise innovative and impactful solutions. We are proud to partner with Mighty C2S program as well as collaborate closely with IT Delhi, our lead academic institution in this endeavor. I extend my gratitude to Ministry of Electronics and IT as well as IT Delhi for their support in this exciting initiative. Good luck to all the participating teams.
Hello everyone, I am Dr. Vijay Kumar, currently working as a principal project scientist at IIT Delhi. My work focuses on digital healthcare, medical image processing, and building affordable real-world solutions using Edge AI. I actively work with platforms like NVIDIA Jetson, Raspberry Pi, and STM32 for real-time sensing and intelligence systems. For the Bharat AI SOC Student Challenge, I am the program assistant. Today, we will be looking at the problem statement 2 of Bharat AI SOC Challenge. Building a touchless media control system using hand gesture on the Jetson Nano. We will start with the challenge overview and the objective, then go through the system architecture and the gesture recognition pipeline, followed by performance target. Next, we'll cover the deliverable, learning outcome, and the practical tips for the building a robust system. And finally, we will end with the Q&A and resource for updates. Let's understand what this challenge is really about. The goal is here to build a system where you control a media player using a hand gesture. No button, no mouse, no keyboard. Everything happens through a camera and the AI running on the Jetson Nano. Your webcam capture your hand movement. The Jetson Nano process them in the real time, recognize the gesture and then send them right command to the media player. So, in the simple term, you are building a complete edge AI system, vision intelligence, and the action all running locally on the ARM based hardware. Now let's look at what you are actually expected to build. Your system should detect the hand gesture in the real time using the camera, accurately classify those gestures and the map each one to a media control command. For example, an open palm could be used to play media, a fist to pause, and the sweeping your hand up and down to control the volume. The goal is to keep the interaction simple, intuitive, and the fun to use. The hardware setup required for this challenge is simple. You will need NVIDIA Jetson Nano developer kit, a standard USB webcam, and the monitor, and a few basic input peripherals such as the keyboard and the mouse. All of these components are readily available in the most of the college laboratory or can be easily procured. The primary focus of this challenge is on the design and the implementation of the system rather than on the acquisition of high-end hardware. Coming to the software, the stack is very straightforward. We'll run the Jetpack operating system on the Jetson Nano, which gives you the CUDA support for the GPU acceleration. Python will be the main programming language along with the OpenCV and the media pipeline for the detecting and the tracking the hand gesture. For the media playback, you can use the standard application like VLC and the libraries such as the PyInput and the Xdot tool to trigger the keyboard control. All of these are the open source and widely used, so getting started should be very smooth. After setting up the required software stack, the gesture recognition pipeline operates as follows. The webcam capture the live video frame, which are pre-processed using the OpenCV to enhance the image quality and ensure the consistency. Media pipeline then detect and track the hand landmark in the real time. These landmarks are analyzed and classify the gestures, which are subsequently mapped to the corresponding media control command, such as play, pause, or the volume control or volume adjustment. The entire process run locally on the Jetson Nano board, providing the low latency, reliable, and the smooth performance suitable for the real-time interaction. Now that we have seen how the software stack and the gesture recognition pipeline works, let's talk about the model development and the dataset strategy. One important point to be noted is that the challenge does not restrict how you design your model or dataset. You are free to experiment and choose what works best for your setup. You can use the rule-based method, classical machine learning, or the lightweight deep learning model, as long as they meet real-time performance requirement on the Jetson Nano. Similarly, you are encouraged to create your one gesture image dataset or video dataset using your webcam, considering the different lighting condition and hand sizes and gesture variation. This will help to make the system more robust and the reliable during the final testing and the deployment before the submission. Once your system is running, we evaluate it based on the three key performance targets. The first is accuracy. You should aim for the more than 90% gesture recognition in the controlled lighting condition to ensure the reliable performance. The second is latency. The complete pipeline from the detecting a gesture to triggering the media action should take the less than 200 milliseconds so the system feels instantaneous to the user. Finally, the system should run at a minimum of the 15 frames per second, providing the smooth and reliable time interaction on the gesture. Meeting these targets ensure that your gesture-based media control system is both responsive and robust under the realistic condition. Now that we know the performance target, let's look at the what you need to submit. First is the source code. This should include your gesture recognition logic, media control implementation, written clearly in the Python. Next, you need to define your gesture set and map each gesture to the corresponding media action. Third, submit a live demo video showing the real-time control of the media player running on a Jetson Nano. This will demonstrate that your system works reliably under the realistic conditions. Finally, include a short report summarizing your design choice, model selection, and the performance results. Keep it clear, concise, and practical. Focus on the showing how your system meets the challenge objectives. By completing this challenge, we'll gain the hands-on experience with the ARM-based AI on the Jetson Nano. You will learn how to build a real-time computer vision pipelines, design intuitive human-computer interaction system, and integrate the hardware-software effectively. Most importantly, you will develop a practical industry-relevant skill that apply to the area like embedded AI, robotics, interactive smart system. This skill will help you not only to complete this challenge successfully but also prepared you for the real world application of the edge AI. Before you get started, here are the few practical tips. Begin with the few simple gestures and make sure they work reliably. Lighting condition can be significantly affect the accuracy. So pay close attention to your testing environment. Focus on the optimizing your pipeline for the speed rather than the adding the unnecessary features. Visual debugging tools like displaying the hand landmark and the monitoring FPS can be very helpful during the development. Finally, keep your demo video clear and the focus, showing that your system in the real time. Following these tips will make your solution more robust and your submission stronger. That brings us to the end of this overview. If you have any question or need support, you can reach out using the official support email shown here. support@armbharatchallenge.com. For the all updates and the announcement, please keep visiting the Bharat AI SoC Challenge page regularly. This page will always have the latest and the most accurate information. We strongly recommend checking it periodically so you don't miss any important update. Thank you for your time and interest. We wish all participants the very best and look forward to seeing your innovative and impactful solution. Thank you.